Hello, I'm presenting the paper Unsupervised Cross-Modal Audio Representation Learning from Unstructured Multilingual Text on behalf of myself and my co-authors. The motivation of this paper is to learn an audio representation from unstructured text to supersede the need for categorical ground truth annotations. This is done by harnessing cross-modal semantic references from rich textual description of acoustic content. And as an additional challenge, the aim was to handle the multilingual content of the dataset. The Europeana Sounds dataset has been developed in the Europeana Sounds project. It is an aggregation of Europe's digital sound heritage. It was collected from various institutions all over Europe. It is a large variety of audio content, especially music, but also contains interviews, preservation of dialects, biodiversity and environmental sounds, radio news, public speeches, and much more. For the evaluation dataset used in this paper, we subsampled about 83,000 audio tracks and corresponding metadata. This contains 26 collections by 30 institutions and spreads over 40 European languages. The method we use in this approach is based on latent semantic indexing. We use this for topic modeling of the textual metadata. Here we see some of the identified models by some of the identified LSI models. Topic 1 contains Latin words, which corresponds to the collection of natural sounds of the Open Up collection. Topic 2 refers to classical music. Topic 3 to Jewish historic music, and topic 4 to spoken language, to spoken voice, such as interviews. And as we can see, these topics spread over several collections, and through this topic modeling, we get a fine-grained semantic description of the acoustic content. And by embedding every metadata of every track into a LSI topic vector space, we can use cosine similarity in the LSI vector space to estimate track similarity. And using this track similarity, we can select positive and negative pairs in an online triplet selection approach. And then we use the audio content of these triplets to train a neural network on audio similarity or audio representation. The audio model we use is based on a convolutional recurrent neural network. And in this network, the CNN stack is used to embed the audio content into a latent representation. And the concatenation of the sequence of this latent representation is used as input for a recurrent neural network to model the temporal representation. The evaluation is based on, we're using a baseline of handcrafted features. This approach has been developed in the Europeana Sounds project. It's a combination of music and audio features. And we're performing two evaluations, using track relatedness by collection name, which corresponds to traditional approaches where categorical ground truth data is available, and our unsupervised approach based on the LSI similarity estimations. The results show that our method outperforms traditional approaches in precision, in retrieval precision, on higher cutoffs, and performs comparable using lower cutoffs. But this is respectively, so our approach only uses about 15% of the vector dimensions compared to the baseline approach. What we can see here in this chart is content is an evaluation of content related terms. So how does the different approaches perform in similarity retrieval concerning content related terms in the metadata? And here we can see that our approach seems to better adapt to the underlying acoustic characteristics of the dataset. Thank you very much. If you have any questions, please send us an email or refer to the comment section.